So good morning, everybody. We are pretty impressed by the number of people. CRDs are a developer topic, and to see so many people interested in that, it's just amazing. We are also surprised about the comic. I think everybody has seen that in the keynote this morning. Fantastic comic, and yeah, we couldn't stop to show it as a first slide today. Yeah, my name is Stefan Schimanski. I'm working for Red Hat. Part of my work is on CRDs.
Well, my name is Mehdy Bohlool. I'm working for Google Cloud. Yeah, that CRD is my project for last year, working on different aspects of it. This one is going to be about versioning and conversion. So first, let's set some terms here. We're talking about custom resources. There are two ways in Kubernetes to define custom resources. One is through custom resource definitions that probably most of you heard, but the other one is aggregated API server, and yes, our documentation called those resources custom resources too. Here we are focusing on CRDs. We're going, from now on, when we are talking about CRs, we are talking about defined using CRDs. And there are sometimes these terms goes wrong that we call it CRD versioning and CRD conversion, but it's actually CR versioning and CR conversion through CRD. So CRD before 1.11 had one version field that you specify your version and group and kind. In 1.11, we start adding this versions list that is going to actually replace the version field. Version field was required. Now it's optional, and if you set it, it should be the first item in this versions list. And if it's not set, that's fine. It will be defaulted to the first item in the versions list. The simplest version definition is actually a name, served, and a storage for each version. Name is obvious, the name of the version that is going to be used in the URL too, or anywhere else we are referring to the version. Served will let you actually disable and enable this version. And I will talk more about that, why we just don't remove it. Sometimes you can't just remove a version. And then storage is specifying which version is going to be used when we are storing CRDs in etcd. Only one of these versions can have this flag on. Only one version should be specified as a storage version. Other than those three simple fields, we actually, starting 1.13, we moved other CRD fields into the versioning. We moved them per version. First one is validation. We had a validation field at top level. Now we have a schema field at each level, at each version. Each version can have its own schema. Because we, for backward compatibility and to make sure that we can do upgrade and downgrades, we did some validation here. If you set per version fields any of these, you cannot set the top level one. So either top level one should be set or per version fields. If top level one is set, it will be used for all versions. If per versions fields are set, the top level should be empty. Because of some, we actually look at many upgrade and downgrade scenarios. There are scenarios that actually an old operator may not know about per version fields and may try to patch the CRD to set a top level field. In that case, we will auto clear per version fields if the top level one is set. But other than that, you should make sure that either top level or per version fields are set. For sub-resources, we did the same. So we can define sub-resources per version. This is very actually useful example. For example, you want to add a status to a new version. Adding a status to the only version you have would have problems because your old controller may not work. Status changes the behavior of your object. So you can actually define a new version and enable status in that version. Also, for additional printer columns, you can define them per version. And again, the same rule, if you set the top level one, it will be used for all of them. And these are starting alpha in 1.13. I'll hand it to Stefan.
Yeah, a bit background about versions. Versions are representations of the same resource. So on the slide here, I have one object. It's called your resource. And it's actually the same, just 3 different representations. So when you create an object using v1, you can get the same object again in v1 beta 1 or v1 alpha 1 in this example. So it's important, it's one object, just representation, nothing else. And to retrieve an object in a different version, of course, we need conversions. And this is the topic of the talk. And you can imagine that maybe your controller creates a v1 and the user uses v1 beta 1 and another controller wants alpha 1. It's very important that you don't lose information. So this conversion must go back and forth between versions, and there shouldn't be any data loss because it's representation and it must be without any information loss. This conversion is very deep in the API server. So you can imagine that we store something in etcd. When we store something in etcd, you remember Mehdy showed the storage version. There's just one storage version, which means when the user sends a v1 object and you have a storage version for v1 beta 1, the version or the object is converted before. So you have conversion basically everywhere, and if you look at this picture here, it can be that on one request you have 2 or 3 conversion calls. So this is central and a reason, again, why you have to be very, very careful to have no data loss when converting. For native resources, this is implemented obviously in Go. So a pod conversion, it's done in Go inside of the Kube API server. For CRDs, we couldn't do that for obvious reasons, so we needed something to put those conversions into. And what we did, we proposed to use a webhook for that.
So we talk about, Stefan talked about the conversion, how we did it in CRDs. So starting from 1.11, when we introduced the versions, we assumed that there's no conversion. All the objects would be the same. That's the first version. We wanted to get the versioning out so people can try it. In that one, we called it a non-conversion. That means the only thing the conversion will do is to set the API versions of the CRs when you go from one version to the other, and assume the schema of that CR is staying the same. So for example, in those version, if you want to add a field, you need to add it to all versions. You can't add it only to one. Or if you want to rename it, you need to rename it everywhere. The schema cannot be different if it's a non-conversion. Then we actually start discussing of how we want to do the conversion in CRDs. We had a long discussion on declarative conversion, how to define it, what is good operator we can have. And I put actually 2 links there. You can go there and see the discussion, long discussion. But at the end, we decided not to do the declarative and decided to go with a webhook conversion. Basically, API server calls to an external webhook to ask for the conversion. And we thought that this is general enough that we can do everything with it, but it comes with its actually problems that I will talk later. But basically what would happen is when Kube API server gets a request for v1 and you have a v1 beta 1 stored in your etcd, Kube API server will send a request to an in-cluster webhook server. It doesn't need to be in cluster, but it's normally in cluster. It's a service. It's called into it and asks for conversion from v1 beta 1 to v1. And then the webhook service will return a conversion response with v1 and will return that to the user. This is in 1.13, and this is alpha. So how we define that? In the spec of the CRD, we added a section called conversion. The first field in conversion is strategy. It will be defaulted to none if you don't have this field yet. If you set it to webhook, that's the only other value that is allowed. If you set it to webhook, you should define a webhook client configuration that basically will point the API server to the service that implements the webhook. It's a service name, it's a namespace, and the connection should be HTTPS on the HTTPS port, or otherwise it won't work. So let's do a demo. So here what I'm going to do is I have a CRD that has some versions in it, and I can actually show you the CRD. So it has v1 with some schema, v2 with some schema, and also I defined a conversion that is a service name and the namespace. So I'm going to create the CRD. Hopefully it works with the Wi-Fi. Waiting. No, it doesn't work. If you're on your phone downloading something, please stop. Let's see. Let's see if I can connect to my phone. Hopefully that works. We'll see. Okay. Stop it and start it again. Okay, done.
There we go.
Okay, works. So the CRD is created. Let's create a CR in CR1 is only a CRD, and it's a custom resource in v1, so we call it foo instance 1. If we get it in v1, what happened? Yeah. Let's do it again. Let's clean everything up and do the demo again. No JSON could be decoded. That's good. But we'll skip that part. It should be something there, but I don't know why. So we try to actually create another CRD, another CR. This CR is actually has a different version, v2, and the API server will return an error, say I can convert it, because we didn't actually deploy our webhook yet. So let's create our webhook. For our webhook, we need some RBAC rules to let the webhook access to it. Oh, I need to talk about this webhook. The one that I implemented here, there is one actually good example of webhook that is in our end-to-end test. You can look at that. It's simply do the conversion between host port and host and port. It divides host port into host and port in one version to the other. This one I implemented here because we did a lot of, we spend a lot of time on declarative conversion. I thought I can actually implement a webhook that do the declarative conversion for us. So the one that I implemented is a declarative conversion based on the schema. So basically, it will listen to the CRDs. It will watch CRDs and cache the schema of different versions of CRDs. And there are some tags in the schema that tells the converter how to convert from one version to another. So if anybody just want to rename, for example, that's the only operation it supports right now. You don't need to write a webhook. You can use my webhook. But this is not official. This is just a demo that I wrote for this talk. So let's create the webhook. So the webhook is created and running. So basically what we can do is we can actually look into the logs on that pod. Let me see if I can get v2. It works now. So let's see if I can actually look at the logs on that pod. See what the webhook gets. What happened? The namespace is default. It should work. Yeah, that's for follow, but let's see. Let's see again. No. Oh, let's see. Wait. Let's try it again. Okay, works. So let me just follow the log. So basically, what is sent to the API to the webhook is a webhook request that has a desired version. API server wants a v2, and the object is passing is actually a v1. It has a field called server, And then the conversion actually renamed that to host. And I can actually show you the CRD to see how I defined it. The schema of v1, in the description, it has something called plus conversion from stable v2 rename the host to this field that is server. So let's go back to the demo. So now if I create CR2 that is in version 2, it will create it. It will convert it to v1 and store it. I can actually get it in v1 or v2. If you see, the v1 has server and the v2 has host in it. Here and here. Oh, sorry. And here. And then it's fun. Let's create a third one. And then let's list everything. When you list it, actually, I listed in v1. When you list in v1, because the storage is v1, no conversion is required. So all of the objects will return without any conversion. But if I list in v2, it needs to convert all of them actually to v2. And now if you look at the logs for this conversion, you see actually that a list of objects is sent to Webhook for conversion. 3 objects sent to Webhook for conversion, and 3 objects returned in v2. It's very important to keep in mind that this list API server can send any list, and it doesn't mean that a user send a list request that we are sending a list of objects to Webhook. For any kind of optimization, we can send more than 1 object to the Webhook for conversion, and the Webhook should convert them independently.
Yeah, one addition, this Webhook, of course, it's called in real time. So it's not like a version was created in v1 and then there's one call once for this object. It's really on request, so on each call. When we add a new version, that's what we do here in the first box on the left. The question is, when will you change the storage version? So v1 beta 1 is new, it's not the storage version, so we keep storage in v1 alpha 1. And at some point, we want to switch, and the question is when. So I switch here, so v1 alpha 1 gets false, v1 beta 1 gets true. This will not have any effect on objects in etcd. So etcd, it has objects in v1 alpha 1, and they stay there. So just on write, so if you update an object or create a new object, then the storage version has an effect, and everything which is written to etcd from this point on will be in the new storage version. At some point, you have to do migration, obviously. To make this easier, we have in the status of the CRD a field called stored versions. So we record all versions which have been storage version at some point in time. And you can use that to know when it's necessary to convert all objects which are maybe in the old version. And eventually, when you decide everything is converted, migrated, and you don't have v1 alpha 1 at all in the system anymore, so etcd is completely updated, then you can say, now let's switch off v1 alpha 1. So the first thing you do, we switch off the surfing. So the version is still known, but a user, a controller, whatever, cannot retrieve it anymore. That's the first step. And the last step would be just to delete the version from the status field. It's very important to really think about when to do those steps. So in Kubernetes, when we introduce a new version, we wait quite some time, usually at least a release, maybe 2 releases, until we switch storage versions. The reason is simple. Users have to be able to roll back. And rollback means you install the old server binary or controller binary or whatever, and it doesn't know the new version, but there might be versions, objects in the system of the new version which was just introduced with the last release. So always wait 1-2 releases, it's just a rule of thumb, and we follow that in Kubernetes. So just, here, that's what you usually shouldn't do. You shouldn't just introduce a new version and directly switch to storage. Storage migration, I sketched it already. It's very important to keep this in mind. Changing the storage version in the CRD does not mean etcd changes. Everything etcd stays the same. So you always have to do migration. Migration means you have to write every object to etcd. which means in the simplest case, what we do in Kubernetes with native resources, we just do an empty patch. Empty patch means nothing changes, but there is a write to etcd. So just list all objects, patch all of them without any change. They are written back to etcd, and you are fine. The migration is done. At the moment, this must be done by the developer of the controller of the CRD. There is a tool in the works by some colleagues in API machinery for a generic mechanism for that, but it's not ready, I think. But this will come, so there will be a generic official way to do that. At the moment, just be prepared to do migrations in your own code. I mentioned already a couple of times, this is about data of the user. So conversion means you change representation of data and do not lose anything. Not a field, not a comma, it's really important. To get conversions right, it's not easy. Everybody who has done that outside of CRDs in native resources, to get them right might take days, many reviews, and many tests. Here's one pattern which is established in upstream in the native resources. We call it round-trip tests. So the idea is very basic, very simple. We start with the v1 object in this example. We put in just random data, so we have something, it's called a fuzzer or fuzzing. So we have a function which can fill the object with random strings, and all the structure is just randomized. Then you convert, for example, to v1 beta 1, to this middle one here, and you convert back to v1. So back and forth, from one v1 to another version and back to v1. And if conversion is correct, it should be the same object. So this test can be, of course, repeated. We do that 1,000 times with random objects, and if this survives, your conversion survives this test, you can be pretty sure that it works. So round-trip testing is very important. There are many, many examples in Kubernetes in the source code you can follow. We also have some library kind of testing library around that. So just take a look at the types we have in Kubernetes for examples.
So again, as Stefan said, round-tripability is very, very important, and I'll discuss it. Before that, I was just going back to what I showed you, actually, the served version. And I told you can just remove a version. That's because in the upgrading your storage, when you are done with a version and you want to remove it, you should first set the flag to false. You cannot remove it because the version is still available in etcd, and API server will not let you do that because the stored version of the status has the version, and it will not allow you to remove the version. So what you should do is disable the version so no other new request comes for that version, upgrade your storage, update the status stored version to remove that version from it first, and then remove it from the versions list. So what can go wrong? Your webhook may stop working for any reason. There's no connection between API server and webhook. What will happen? It's very important to understand the webhook calls is on demand. So if they're failing, everything else works. Just that CRD, that CR that you're trying to access and needs conversion will fail. So other types works. If you request for the CR in the same version as a storage, it will work. If you try to store it in the same version as storage, it will work. But if it needs a conversion, it will fail. So for emergency, you can actually try to get the CR in different versions to see which version is the storage version, even if you don't know that. Sometimes looking at CRD doesn't help you because you don't know when the CR is stored, what storage version was at the time. But you can just try different versions to see which one is working and patch it or do whatever you want with it to make it work. But you should make the webhook work as soon as possible. A conversion can fail for a subset of CR stood. Your webhook may still work for, the connection can be available between the API server and the webhook, but the webhook conversion may fail for some of the CRs. The same concept, only fails for those CRs, nothing else. And the last one is actually webhook returns a bad conversion. Here, it's something that is not round-trippable. And again, putting a stress on this because this is a failure that you don't see if something goes wrong. This is a logical failure. You don't see an error from kubectl or an API. Things will work, seems to be working normally, but you will have data loss, users' data loss. So very, very important to run tests on round-tripability because this is not something that you can catch in production easily. So we'll have more about this in SIG API machinery deep dives. If you are interested, please come and we'll be available to discuss more implementation details of that. What's beyond this? What are we going to work on in 2019? So basically the plan is to make the CRD conversion, the CRDs generally, as a GA feature. There are a couple of blocking issues that we are working on. CRD conversion and versioning is still alpha. It should be better in 1.14, and it should be GA version or two after that. There is an issue, 58682. If you're interested, just look at that issue. There are a list of things that we are working on, list of blockers, and list of things that we wish we want to work on, and some people like to work on. But the main ones that blocks GA is generating OpenAPI spec for CRDs. Actually, CRDs needs to actually provide their schema through the validation schema that we are calling a schema per version right now. But we are not serving it. If you are providing the schema, it's not served for kubectl and other, other client generator, for example. So that's something that we are working on. It barely actually missed 1.13. It's going to be in 1.14. Quota support is very important. Defaulting and pruning is something that we have a design doc for, and the conversation is actually going on it. And there are a number of smaller issues, but these are the main ones that we are working on.
Yeah, this issue which is listed there has many, many more topics, and some days ago it was updated, so we have discussion what is really needed for GA, and as Mehdy showed, those are the points here. There are many more, and some of them are completely undecided, which means there's no consensus. Most of them have no proposal attached. So I listed some here. If there are some which are really critical for you, come to us, come to the SIG meeting. If you're able, write a proposal for that, start the discussion. We know we cannot do all of that into 2019. That's why we have selected those here. Those are really, we won't go to GA before those are solved. That's basically the plan or what you want to do. Yeah, CR conversion. So this is kind of a takeaway slide. So webhooks, that's what we have now. It's alpha. This means in 1.13 you have to enable it manually. There's a feature gate for that. You can play with it, but of course it's not ready for production. As Mehdy said, we plan to enable that as beta, so it's enabled in every cluster which has beta features in the next release. Let's see if the alpha phase goes well. This is the plan. Yeah, you see the picture of the architecture, and yeah, it cannot be said often enough. Conversion is not easy. It's hard to get it right, but it's about user data, so this is really important. So take care, round-tripability, it's an important point here.
And what I discussed, what most of the discussion was around the declarative conversion. The people that liked that was mostly because of the round-tripability, because we can actually make sure a declarative conversion is round-trippable. But when it's a webhook, we as API server, as Kubernetes, cannot have any guarantee. We are calling into a webhook and the conversion is happening there. So it's up to the webhook developer to make sure that it's round-trippable and the conversion is logically correct. I will put all of the codes and demos on my GitHub page. If you like to see how I did it, or if you contribute adding some operators to it, or see how it's done, it will be available on my GitHub page.
Yeah, I think we are through the slides, so we have some minutes for questions.
Go ahead. Is there a microphone around? Seems that I can repeat the question.
Yeah. So the question is about defaulting. With defaulting, I guess you have the same question whether to
Yeah. So we have admission. Mutating admission webhooks can be used for defaulting today. So there is a way. Admission is not really where you should do that from an API machinery point of view. The proposal we have is about declarative. So they have, in the Open API validation, there's a field default, and you want to apply that. In the deep dive, I have a slide where defaulting is done. So maybe you come there, you will see it. Yes?
I'm not sure I understand what you're talking about the round trip. You started by telling me about a change in the schema for CRDs that looks like it's not round trip.
So the change itself is not round-tripable. So when you change something, for example, renaming something, renaming a field is round-tripable because when you go from V1,
it depends a lot on the operation you use. All operations should have an inverse, right? This can be easy in some cases. Rename can be inverted, obviously, but there are cases where this is not possible. There are long discussions for native types if this happens. Sometimes one has to accept it, that something breaks. Can also happen. The example is host port. So having host and port in one version and having one string for both in the other one. It's also invertible.
That's easy. But I mean, you started showing me, for example, one, the newer CRDs, you have a list of things.
versions, yes.
Okay. But this is about, this is about the CRDs, it's a meta level, kind of.
Exactly. That's an example.
And exactly about this question, there was a proposal with, 1,000 comments, how to get that right. He talked about we only want top-level schema or the special version schema, not both. We cannot mix them. There's a long discussion about that. Maybe it's nice to read that to really understand how to solve this case. So it's complicated, and one has to put invariants around the types like this, either top level or version, to make it round-tripable.
So and it's important to look at it this way. Yes, the CRD itself, we're talking about the conversion of CRs here, but CRD is an object in our system, and we need to be round-tripable. But when we store it still in the old version, and going from old version to new version and coming back to the old version is always round-tripable right now. When we change the storage, then we need to actually keep per versions. Even when we are going to V1, even if we are doing that, we need to somehow keep the information to make it round-tripable. But right now, we are storing in old versions, so we don't have the round-tripable problem yet. But if we store in new version, that's yes.
Maybe an answer for your question. So we had many cases where we used annotations. So we moved new fields into annotations in the old version. That's one solution. Yeah. It's not secure because those are not protected sometimes for native resources, so there are many consequences. In other cases, we also added the new fields in the old version just to make this round-tripability possible. So you change the old version. Clients will maybe just drop the fields. I mean, the fields are there. They are returned via the request, the response, but the clients don't have them in their Golang struct, so they drop them on decoding. So this is also a way. But there's a long discussion around that, how to do that in Kubernetes in general. It's not a CRD problem. It's very, very general.